Hello, this is Vishnu Nair from Cypress Ranch High School. Temper foam is one of the NASA's top 10 spin-off technologies. You can see this in the mattress in which I sleep every day. Please have a closer look at the material. I'm so surprised to see how this technology helps us in our daily lives. Let's have a deeper look at this. We all have been fortunate to receive benefits from NASA's spin-off technologies for more than half a century. Temper foam, initially known as slow spring back foam, is one of NASA's top 10 spin-off technologies, which has made significant positive impact on us as world's consumers. The idea of temper foam was originated back in early 1960s when Apollo Command Module and its astronauts could use it for smooth takeoff and safe landing of its astronauts. An aeronautical engineer named Charles Yost worked on this technology and later helped NASA to help Ames Research Center to develop airplane seating. The temper foam was featured prominently in NASA's spin-off 1988. The foam material was designed to reduce the incredible G-forces being applied to the body that could conform to each astronaut's shape and hold this conformity. The foam was found capable of evenly distributing body weight and temperature and regain its previous state easily. The foam's high energy absorption helped the astronauts during liftoff. The benefit of this spin-off technology is manyfold. The temper foam helps passengers with long-duration flights to stay more comfortable. The foam's weight distribution and temperature sensitivity helps the severely disabled and bedridden people. The doctors could customize the foam to support patients by adjusting pressure on several parts of the body. In addition, it is widely used in prosthetic limbs because it can reduce the friction between the prosthetic and joints. The foam is also used commercially in padding for motorcycle seats, custom body molds, dressmaking, and the protection of race car drivers. Few other applications of temper foam are athletic equipment, football helmets, and chest protectors. In the 1970s and 80s, pro football's Dallas Cowboys team used it to line players' helmets to minimize the impact on the field. Shoe manufacturers used the foam to create special high-comfort insoles. In hospitals, mattress pads and wheelchair seats made from the foam support patients with painful, dangerous sores on their bodies. The foam is now widely used in the foam in place seating, FIPS for short, which is a custom molded seating solution for the severely disabled. The FIPS technology is used in NASCAR, Formula One, Indy Racing League race cars, and Champion Auto Racing Team. At one point of time, one NASCAR driver who used FIPS in his car seat walked away from a serious car crash unharmed. Temper foam is also used to make saddle pads and racehorses. We'll have a look at how this product is manufactured. Take a look at this picture of the seat of a motorcycle. Even though there is slight variation in the chemical components used by different contractors and companies, temper foam mainly uses open-cell polyurethane silicone. The temper foam evenly distributes the weight and pressure as well as providing shock absorbency. The foam material, after compressed to 10% of its size, could regain its original shape easily. Temper foam is temperature sensitive. The more the temperature, the more the compression rate is. Here's a cross-section of the temper foam. Please note that it contains lots of air cavities. When pressure is applied, the air is transferred from one cavity to another. Let's take a look at a picture. The temper foam possesses viscoelasticity that helps it rebound quickly and return to its normal shape. Its quality is primarily dependent on the density of the chemicals used to build it. The indentation load deflection (ILD) rating will tell us how hard or soft the material is. For instance, 25% ILD rating is the number of pounds required to achieve a 25% compression of a 4-inch thick foam using 50 square inch indentation. The higher the ILD, the firmer the foam is. Low ILD has the advantage of pressure point reduction. However, it has the advantage of lack of adequate support, which in turn can negatively impact the user's back. This disadvantage is overcome by providing support in different layers. The indentation force deflection, IFD, measures the softness of the foam. A circular indenter with 50 square inches in size is pressed against a foam sample with thickness 100 mm and area of 500 mm. It is first placed on a flat perforated table with holes to allow passage of air. After pressing, it is allowed to recover for 6 minutes. Then the force is measured for 1 minute after achieving 25% indentation. The lower the score, the lesser is the firmness of the temper foam. Unit of measurement is pounds force. Another measure of the foam is its resilience. This measures the foam's spring action. The more resilience, the more spring action the temper foam will provide. The extent to which temper foam can be stretched is called tensile. Tensile is measured in pounds per square inch. However, this value is not used because the mattresses are normally compressed instead of stretching. Finally, let's have a look at the chemical composition of the temper foam. The chemical composition of the temper foam consists of chemical substances with linear polymers, which are made of carbonate groups. This group is formed by the chemical reaction between polyol and dicyanate. While polyol is a multiple hydroxyl group containing alcohol, dicyanate consists of two isocyanate groups. The foam contains a polyol and dicyanate in the ratio of 1 to 2. When polyol and dicyanate react with water in the presence of catalysts such as tin and amines, it creates cells very similar to bubbles. Surfactants control the bubble size by lowering the liquid surface tension. These chemicals react exothermically and a liquid is formed. Then the liquid is poured into a slab mold at a certain rate and temperature. The hot liquid then is agitated within the mold as the air is pumped out, forming an open cell structure. The mold then dries quickly to provide the polyurethane foam. The slab mold is cooled to remove the foam. Even though the exothermal reaction takes just about 5 minutes, the whole foam manufacturing process takes about 8 hours. It is interesting to note that the temper foam technology is spinning back to NASA, where the agency recently built an obstacle course that placed over a 5-inch thick cushion floor to evaluate astronauts' post-flight performance. This is due to the fact that the astronauts who return from space experience difficulty with balance as they readapt to gravity on Earth. Actually, this cushion floor provides an unstable support that increases the challenge for astronauts regaining their equilibrium. Then their psychological responses were monitored to negotiate their way through this course. NASA's Spinoff technology provides numerous benefits for world's consumers. If we look closer, the invention of temper foam has a wide array of applications that make significant impact on our daily lives. Of course, we spend 1/3 of our life in bed. We should be giving gratitude to NASA's curiosity and inventions that not only helps us explore the unknown worlds into space, but also helps make our daily lives comfortable. When talking about NASA's spin-off technologies, temper foam is the most striking to me. Thank you for watching.